Hey there, welcome to the Hack the RADKit series, where we explore together how to leverage our existing RADKit deployment using the power of coding. My name is Alfonso, I'm a developer advocate at Cisco DevNet, and I am very happy to bring you today a very interesting use case that has to do with leveraging AI to actually talk to my network. At the end of this video, we will have a fully enabled system that allows us to actually chat to our RADKit network and do all sorts of things, all sorts of different read and write operations. We will do this by using the FastMCP Python library and with very few lines of Python code. If you're not familiar with the MCP technology, well, let me tell you, it's a very interesting and fairly new technology that enables us to do all these integrations with our favorite LLM. And let me tell you a little bit about it. MCP is often referred to as the USB-C port of AI. Because, well, you see, before this technology, if we wanted to integrate our favorite LLM with different systems, we would have to bolt in their very unique APIs. And this was very cumbersome thing to do. So let's say, for example, that I wanted to enable my LLM to read records on a database, to send emails, or to book appointments on my calendar. Each and every one of these systems would have its very own API, and I would need to enable my LLMs to make use of these resources. That was very cumbersome, and it wouldn't work all the time. However, with this new technology, MCP, or Model Context Protocol, what we can do now is to unify all these different proprietary APIs onto a single streamlined and standardized protocol that all the LLMs can understand. When we talk about the MCP technology, we need to mention the MCP servers and the tools within. When we want to integrate our LLM with different systems, with different services, ideally we will have an MCP server for each. In these MCP servers, they will have a transport mechanism that will be used for onboarding and interaction with our favorite LLM. We only have two to choose from. It can be either STDIO, which is a CLI interface, or HTTPS. So now that our MCP servers are onboarded, they will announce to the LLM which are the tools available for using. And each server will be like, hey, this is my collection of tools. This is how you use each of these, meaning these are the input parameters. This is the expected output. But also the MCP servers will provide context to my LLM. That means, hey, this is when you would use these tools for accomplishing this specific task. And maybe if we have dependencies, this is how you will use wisely these tools. So what we will do in this video is to actually take all of this and create our very own RADKit MCP server. On the background, we're going to have our onboarded network with all our onboarded devices. We will use a remote user to enable this interaction with our RADKit network. But at the very same time, we will have a collection of tools that our LLM will make use of with the MCP protocol. We have a project under the official Cisco DevNet repository, which contains all the code that we are about to see in this video. It goes by the name of RADKit MCP Server Community, and here you are going to find all the different files, scripts, all the different instructions to get you started with the building of this MCP server. Here you have all the dependencies and a brief explanation of the tools that we're going to build, and also some installation and setup instructions. We're going to go through these ones live here in this video because, well, we included a small assistant to help you get started with two things. The first one is to onboard your remote user so we can do authentication based on certificates. That way, you don't need to be authenticating every single time that your MCP server performs an operation in your RADKit network. And then the second tool is for creating an environment file. This file will have the information about your remote user, your RADKit service, and also the transport method you want to use, whether it's STDIO or HTTPS. So without further ado, let me jump to our Visual Studio. Here I have already cloned the project. And the very first thing that you want to do is to execute our setup script. If you have a Linux or Windows or any Linux-based environment, well, we will execute different scripts. In my case, ever since I'm on a Mac, I will do setup.sh. What's going to happen now? First of all, we are going to be creating a virtual environment with the Python libraries that we will need for enabling this MCP server. It's based on our requirements.txt file. In my case here, I have already created the virtual environment, so it's already there. Then you will see here this very small, cute prompt. We want to choose the first option, which is to onboard my user for non-interactive authentication. I will go to that one. Then I will put my username, so that I have here on my other screen. Just let me put it there. Nice. Then I will be prompted for the authentication. You can see here that my web browser pops up. I'm prompted for all this information, my Duo authentication. Let's wait a little bit for it. And just a little bit more. That's it. I have this authentication screen. I go with accept. That's done. Let's go back to our Visual Studio, and that's it. My user is already authenticated. I'm gonna tell it to overwrite the certificates, and I'm gonna create a new set of certificates with a password. So I'm just gonna put my password here very quickly. I'm gonna put it again. There we go. My certificates are already installed, and now I can use them to authenticate my MCP server. Now I want to choose option 2, which is to generate the .env file that my MCP server will use later on when I activate it. So I will go for that one. It's going to prompt me for my username, which is the one here, then my service code, which is this one here. Just a second, from my lab. Lovely. Then the password that I just created. So that's going to be, just give me a second. Lovely. And then the mechanism that I want for authentication. So it can be either STDIO or HTTPS. I'm going to go with the default one for this demo, STDIO. And that's it. I generated an env file for authentication and for operating my server. So just exit, and now let's get hands-on with our code. This is the environment file generated by my assistant. You can see here that we have some different variables. We have our encrypted password for the non-interactive authentication. We also have our remote username, our service code, and also our transport method of choice, which in this case is STDIO. We are going to use these variables for our script, for the script of our MCP server. You can find the file in the repository mcp_server.py. Here we have all the code that we need to create and operate our MCP server. Let me start from the very top. I'm going to use the FastMCP library and also the RADKit client SDK for Python so I can create my client and service instances to connect to my RADKit network. I will load all the environment variables and I will create an MCP server instance. Then allow me to scroll all the way to the bottom. I want to show you something from the very beginning. Whenever I activate this MCP server, immediately I'm going to set up the transport mechanism. If we have HTTPS, I'm going to be using a host and a port that should be included in that .env file. Otherwise, I will be using just the stdio transport method for our mcp.run command. Now that we have our transport set up, it's time to create our different tools. But before that, I want to create a single instance of my RADKit service that allows me to do all the operations that I need using a single connection. I don't want to be opening and closing connections every single time that one of my tools is being executed. With this in mind, let me just scroll up a little bit. We have created this class called RADKit Service Manager. It follows a singleton design pattern, meaning that we have a single instance of this class. What we will do when we create an instance of this is that we will create a connection. This is the code that we have as an example on the RADKit documentation. We are creating a client. Within this client, we are getting a connection to our specific service using the specified username and the security certificates that we created before. Once we have this, we will be able to use this single instance throughout the entire script. We are going to get that instance with this, and then we are wrapping it up with this function, get RADKit service handler. Whenever I want to do something on my RADKit, this connection will exist already. It will be active, authenticated, ready to be used, and I will use it later on in each and every one of my tools. You can see here that I have the definition of the 3 tools that I mentioned before. Each and every single tool has the decorator mcp.tool, because with this one, the FastMCP library will handle everything by itself. That meaning creating the documentation of each tool and sending it to the LLM whenever it queries my MCP server. You can also see that all my definitions are declared as async because I want to enable my LLM to call this in parallel so that I'm not blocking the operations whenever I am using these tools. So let's get into the first tool, get device inventory names, very quickly. You can see here that in the docstring of the tool, I am providing all the context that my LLM needs. I am telling it, hey, this function returns a string with the names of the devices onboarded in my Cisco RADKit service inventory. Use this function first and foremost whenever you are asked about devices, network, or all devices. And this is what I'm going to give you back. It's this dictionary format with all the names of my devices. And you can see that the code is super simple. It's very few lines of code. I am getting from my RADKit service handler instance, I'm getting it, then I am putting it on the loop so that I can block the operations in case like this threads collide and such. I'm blocking it there. But then let's focus on the most important part of this. It is this line here. I am getting the inventory from my RADKit service and I'm getting the values from that inventory. And I am just returning a string in which I have this format here. I am just getting the names of all of those devices. That's it. Easy peasy. I don't need to do anything else. Let's go to the second tool, get device attributes. Here you can see that the docstring, like the documentation and the context, is a little bit bigger, but it's still very easy to understand. And well, that's my intention. I want my LLM to fully understand all of this. I'm telling it, hey, this will give you a JSON string with all the inventory attributes of the device that you pass as an input. And this tool is very safe to call in parallel. So if you need to know information about a series of devices, you can use this tool as many times as you want in parallel because it's a read-only thing. It is safe to do. And then I am putting here some inputs, some examples of return statements. I'm putting here the documentation, and I'm even putting here an example. I want to help the LLM to do this. I want to help the LLM to fully understand what I'm doing. And then finally here, we are getting the service handler. We are querying from the specified device here. We're getting the attributes internal. That's it. This comes from the RADKit SDK. And I am just getting all of that, transforming it into a dictionary, and then just giving back the JSON dumps. As easy as that. Let's go to our final tool, which is the most important one. execute CLI commands in the device. You can see here that I am passing the target device and also a list of strings which contains one or more CLI commands. And I am giving here as well a lot of information, a lot of context to my LLM, so I can use this tool wisely. I'm telling it, hey, you should use this tool whenever you are asked to do any CLI operation on a specific device. It can be either read or write operations, but don't just use random CLI commands and try to put them on the device. You should know that whatever you're going to pass is compatible with the target device. I'm saying that here, right? You can get the device type or platform using the other tool, get device inventory names. And here I am passing the arguments, I am passing the return statements. This is an example, right? I'm telling the LLM what to expect out of this tool. And then a very important thing, when we have RBAC enabled in my RADKit service, we are restricting users to do operations on specific devices. That meaning that whenever we execute this operation, this tool, it may or may not be enabled for the user that I onboarded in this MCP server. That meaning that I should flag that when I get an error. So I'm giving enough context to my LLM to know that. I'm telling it, hey, if the exception that you get reads access denied, that means that RBAC is enabled and the user that you have onboarded doesn't have the permissions to do things in this specific device. So you need to flag that to the user. Then, well, after all this docstring with the context and the usability and such, the actual Python code, you can see here, it's just a couple of lines of code. I am using my RADKit connection. I am getting the target device from the inventory, and I am executing whatever commands I have as an input, and I am just getting the results. Then for all of those results, if it was a single command, I am getting just the data from that output. If it was more than one command, I am getting all those outputs, packing them together on a string, and I'm just giving that string back as an output from the tool. So you can see here very few lines of code. It's much more about the docstring that contains the usability and the context, so our LLMs know how to use these tools properly. So having said that, let's put it to action. Let's onboard it on my LLM and see how this works. For this demo, we are going to use the Claude LLM and the Claude Desktop as our platforms to test our RADKit MCP server. For doing that, we need to use this JSON file. It is included in our repository, and basically what we need to specify here is the collection of MCP servers that we want to onboard into our Claude Desktop application. You can see here that we have MCP servers, and then we have here our own RADKit MCP server. Two parameters here. The first one is the command that Claude will use to execute our server. In this case, we need to specify that we will use the Python instance in our virtual environment. And then the second one is the arguments to actually trigger that MCP server. In this case, we just need to specify that Python file where we created our tools. You can see here that we are using absolute paths for both our virtual environment and our MCP server.py file. So now that we have this ready, we need to copy it on a specific location within our host system. In my case, ever since I'm using a Mac, I'm going to copy it into this specific location. It will change depending on your operating system, but don't worry, I have all the commands that you need there in the repository. So now that this is in the place where it should be, it's time to fire up our Claude Desktop and see if that RADKit MCP server is onboarded and ready for some queries. I have already opened it here. Let me show you. This is my Claude Desktop environment. And if you go here to the tools part and you scroll down a little bit, there you go. There you have it, our MCP server for RADKit. You can see here are the 3 tools that we created, and this is pretty much ready for some nice queries. I'm going to start with something very simple. I'm going to ask our friend Claude to tell me, Just a second, I have my queries here somewhere else. Yes. Can you please tell me, Claude, which are the devices in my network? So Claude knows, because it has all the context that it needs, it knows that there's a tool for that on my RADKit MCP server. You can see here that it is using the tool get device inventory names, and it is letting me know that it is using a tool, that it is not coming up with some random information from the internet and whatnot. This is real data from my real RADKit deployment through the RADKit MCP server. How cool is that? You can see here that I get the information, I get all the names from my devices, and here I have my 10 devices from my network inventory. So would you like more details about any specific device? Yes, of course, Claude. Please allow me to make you one more question. Let me put this query here very quickly. Claude, please, from this specific device, I need a nice table, I need a nice summary with the status of all my interfaces. Can you do that for me? Yes, of course. Claude, first of all, will get that information. It will get my target device. It knows that the command is show IP interface brief. Then it will send that command to my device, and it will get this raw information. However, it will process this information and show me this beautiful table with all that summary. 18 interfaces total, 4 of them are operational, and the others are down. So this is pretty cool. This is like read-only operations, but it can go beyond that. Let me try Claude with something much more complex. I have this query here. Now I'm going to ask you, Claude, hey, this is awesome, but can you please create an ASCII diagram representing my whole network? I want some ASCII art with the topology of my RADKit network. Let's have a look at this. It will go through the different devices. It already knows which are the devices in my inventory because it asked it before. It is getting the attributes of each, so it knows which kind of devices these are. If these are iOS XR, iOS XE, NXOS, whatever. It's doing this in parallel, firing all these queries at the same time. And then once it has the information, it's going to do something else with this information. You can see here, now that it knows which device types and families are all the devices in my inventory, it will send CDP, LLDP neighbors commands to each and every one of these devices. You can see here that we have these execute CLI commands in device. It is sending show CDP neighbors to each and every one of my devices. And it knows which command to send because it already knows which kind of platform my devices are. You can see here from this other tool, get device attributes, that it got that information. So now it is sending these commands to each and every one of my devices. And then it will do cross-checking of all this information and tell me what's the topology. There will be some devices that are offline. We will see that here later on in a nice summary. You can see here that some of the CDP neighbor commands are complete, and I get all these raw outputs. So later on, once Claude has all this information from all the devices that are reachable, it will do some cross-checking and it will render all the network topology on some nice ASCII art. And voila, you see here that Claude finished querying all the devices. It finished crunching all that data, and now it is ready to do a representation of that network topology in ASCII format. You can see here how it is being rendered. You can see here all the different device connections, all the different device types, and how each interface is interconnecting all the devices within my network. You can see that here. You can see we have some devices standalone, we have some devices with access issues, and then here it is giving me a summary of all these different connections. You can see here, and then finally some devices that couldn't be queried because they most likely are offline. This is something pretty cool, isn't it? So far, we have only done read-only operations. We have only queried things from my RADKit network. What if I actually want to change something? What if I actually want to commit some configuration in any of these devices? We can actually do that because at the end of the day, we have a tool enabled for read and write operations. And Claude is very clever and it knows which CLI commands are the right fit for whatever I may need. So let's try it out with this request. Hey, Claude, buddy, can you please change this interface description from this device to DevNet demo? Let's see if you can make it happen. So it is thinking which are the commands that I need to do. It already knows. It also knows which device type is this router, so it doesn't ask my other tool. And it knows that for doing that change, it needs to run all these different commands. So I am sending all of them to my RADKit server and then to the device eventually, so they are executed in sequence, but with the same run of my tool. And you can see here that it has successfully done that. The change is there. We are all good to go. If after watching this commit operations demo, you have some pretty serious security concerns, well, yeah, let me tell you, those are pretty valid. You're not alone. When we enable our MCP servers to do commit operations on a network, well, things can go pretty sideways, you know. At the end of the day, it is the best judgment of the LLM what determines which are the commands that end up being committed in our RADKit network. And that can lead to some serious scenarios. However, there's a way to add a security layer on top of that so that we can have some restrictions in what can be done from our MCP server. In this case, we can do that straight in our RADKit service. You can see here that I'm on the RADKit admin webpage, and I have here my generic user, the one that I onboarded in my RADKit server. In my MCP server. If I scroll down, you can see here that RBAC is enabled. That is role-based access control. I am going to remove this tag, and that means that this user is no longer enabled to do any operations, any commit operations in my network. So I'm going to ask Claude to do, once again, a commit operation in this device. And let's see what happens, right? I'm asking Claude, hey, buddy, can you please change the description of this interface in this specific device to DevNet demo? So it will go business as usual. It knows which commands to use. It will get, well, first of all, it will get the inventory names, yes, to verify that the device is there. Then it will execute the command right away. But then let's see what happens. It got this error that the access is denied because this user no longer has access to the device. So then it is giving me here some recommendations. It's, hey, it seems like RBAC is enabled. You can please check what's your access. You can please check what your user can do. You fix it on your end, and then come back to me and ask me to repeat the operation. So this is like a very basic yet super useful layer of security that we can add to handle our MCP server interactions with our RADKit environment. So this is it from my end on this video. I hope that you liked it. I hope that you found it super useful. And now the invitation is for you to leverage the capabilities of this MCP server and do all sorts of incredible things in your network. So please give a like, comment, and share this video. Also, the repository is there for you. And let me know how it goes when you hack the RADKit.